Hey, this is Mr. Doro. Today we're going to be talking about dilution of solutions. And you're going to be able to calculate new molarity or volume when a solution is diluted, or calculate the original molarity or volume. Dilution is when we add more solvent to a solution to reduce the concentration. If you look at this picture, this is concentrated orange juice that you would buy in the frozen food aisle at a grocery store. So you add water to that, and then you get the orange juice the way we would drink it. This orange juice is from concentrate, it says right on the label. So that means that it was actually made from something like this, a concentrated orange juice, and you diluted it down. In chemistry, we usually have a stock solution, and the stock solution is a high concentration. This is concentrated nitric acid over here, and then we just dilute it down to whatever we need. We do perform some calculations to figure out the concentration we need, and we determine how much water we need to add to that to dilute it down. So we have the concentrated down to the dilute. It's important to know that when we dilute, we don't change the number of moles of a solute. The moles of the solute before the dilution are the same as the moles of the solute after dilution. What you're really doing, though, is you're adding solvent to it, and you're changing the concentration of it. So we've seen this picture before. It has these little solute particles that are dissolved in here. And if we poured this into a bigger beaker and we added some more water or some more solvent, it still has the same number of moles of the solute in before and after. What changed was the amount of solvent and the overall concentration. In order to find the moles of the solute, you can take the molarity and multiply it by the volume. So you have molarity times volume here, and remember, molarity is moles per liter. Volume is in liters, so when you multiply these two, you can see that the liters cancel each other out, and you're left over with moles. So we have a formula that we can use for dilution. It's right here, M1V1 equals M2V2. The ones in each one of these mean this is before diluting, and the twos are after diluting. Something that you really got to remember here is this V2 right here also is your final volume. That means that if you added water to it, which you had to dilute it down, then that is what you started with and the water that you added to it. When you have a problem dealing with dilution, you really need to read the problem carefully, because some of this stuff is hard to pick out, and what you need to find also. You need to look at the units, those should help you out, but you need to really find out what's before and what's after. So if we look at this problem right here, a student wants to make, notice this is what they want to make. This is what they want to end up with. This is a volume, and so this we're going to label as V, and since they want to end up with it, that's V2. That's our final volume we want to make. This is a molarity right here, and this is, so that's M, and it goes along with that volume, so that's M2. That's what the student wants to come out with. This is what they started out with. How much 12 molar HCl does she need to start before diluting? This is a molarity here also, but this has got to be M1. That's what she started out with. So, and the question wants us to find how much here, which is a volume. So we start out with our formula. Notice I'm going to write out the formula each time. M1V1 equals M2V2. M1 I know is 12.0 molar. V1 is what I'm going to solve for. M2 is 3.00 molar. And V2 is 500 milliliters. Now it may concern you that we have milliliters here, and we've always changed milliliters to liters. But realize these molar are going to cancel out, and whatever unit we have for volume on this side, that will end up being our volume that we solve for on this side. So when we solve for this, we obviously would just do 3 moles, 3.00 molar, times 500, and then divide by, this has to come over here to get V1 by itself. And you end up with 125. The units on this are going to be the same units as my volume on the other side, 125 milliliters. In scientific notation, that would be 1.25 times 10 to the second milliliters. That's my volume that she needs to start out with in order to make that dilution. Here's another dilution problem. Francisco has 36.9 milliliters. From the units, I can tell you that that's a volume of a 6.00 molar, that's molarity. stock solution of calcium chloride, what volume would he be able to make of a 1.00 molar solution? And so this is my molarity also. Notice he wants to make this, so this is going to be my final M2. This is what he started out with, V1 and M1 right up here. So I'm going to plug these in, writing out the formula again, and I'm going to write the units. M1 V1 equals M2 V2. And so for M1, I'm going to put 6.00 molar times my volume 1, which is 36.9 milliliters, equals M2, which is 1.00 molar, times V2. And so when I solve for V2, I get my V2 is equal to 221.4. I check my sig figs out. This has 3 sig figs because of the decimal. This has 3 sig figs. That has 3 sig figs. So I want this in 3 sig figs, which would be 221 milliliters, or 2.21 times 10 to the second milliliters. That's my V2. Put a box around that. Now, is that really what I'm asked to find? I look back up at the problem. What volume would he be able to make? Well, my V2 is my final volume that I end up with, and so yes, that is answering the question. It's always good to go back and see what the question's asking. And we have one more type of problem. This one's a little bit different also. It says how much water would Allie need to add to 65 milliliters of a 1.96 molar salt solution in order to get a new concentration of 0.500 molar. So let's label the things that we do know here. We know that this is a volume right here. This is a molarity, and this one's a molarity. It says here that this is her new concentration, so that's going to be M2. This is going to be my V1 then, and this is going to be my M1. There's a little trick to this one though, because it says how much water would she need to add to it. It doesn't say what is the final volume. We have to solve for the final volume first, but then we have to do something different too. So I'm going to start out solving for the final volume. M1 V1 equals M2 V2. And M1 is 1.96 molar. V1 is 65.0 milliliters. Notice put in the units here each time. 0.500 molar. And V2 is what I'm solving for. So to solve for V2, I'm going to take 1.96 times 65 divided by 0.500. And I got 254.8, which we're going to put in the correct number of sig figs to 255 milliliters. And the question, this is my final volume right here, but remember the question says how much water would I have to add to this? I started out with 65 milliliters, 65.0 milliliters. So that 65 milliliters is in this already. So in order to get to how much water I had to add, I need to subtract that 65 milliliters from it. So minus 65.0 milliliters. And when I do that, I get 190 milliliters of water added. So here are some problems for you to do. They are all a little bit different. This one says, it's just like the last one we just did, how much water must be added to this, and so watch out for that. This one says you had this much water or solution initially, you added this much water. This is not your final volume. So your final volume, you got to do something, you added that much water to it, and this one's pretty much just straight up a dilution problem, this last one. And here's what those answers look like so that you can check them out and see how you do. Good luck.